Cool. I think we can get started, and if people still joining, I'm sure they can miss out on the intros. So really excited to be here today. Today we're hosting a joint webinar with our partners at InfluxDB. And while we'll be talking a bit more about Quix and InfluxDB later in the session, really the majority of the session we will focus on the challenges that industrial companies face in moving towards Industry 4.0 and how to overcome those. So if you have any questions during the presentation, please feel free to put them in the Q&A. We'll try and address all of those at the end. I think there'll be plenty of time. So yeah, any questions that you come across during the presentation, pop them in the Q&A, and then we'll get to those. So right, let's kick off with some introductions. So my name is Cara. I lead product and go-to-market at Quix. I'll be hosting this webinar today, and then I'll be joined by Ben, who will introduce himself in a second. I've spent most of my career working in open source data infrastructure for various industries, and I'm really passionate about discussing, how investing in data and data infrastructure can really have a meaningful impact in businesses. And so I'm super excited about today's discussion and really excited to have Ben on board today. So over to you, Ben.
Yeah, thanks very much, Cara. And also jump in if my connection gets a bit choppy. I can turn my camera off or something like that. But yeah, fantastic to see so many of you here today, and yeah, really, really grateful to have the opportunity to present with a partner quick. So yeah, my name's Ben Corbett. I'm a solutions engineer at Influx. So basically, I'm the technical arm of the commercial team. My whole existence revolves around helping for customers to understand if InfluxDB and the wider ecosystem of their tech stack is going to be a good fit to solve their challenges. And if it looks like it is, making sure everything's best practice, helping with deployment, getting set up, all of that kind of stuff. I come from a background in software delivery, mostly condition monitoring based platforms across kind of manufacturing, energy, agriculture, construction, and everything, transport. And I worked there for quite a few years. Before that, was a mechanical engineer. So actually, my route into software was IoT and condition monitoring platforms. And I think when you work in that space, it's impossible not to know about InfluxDB. So I've been here for about 3 years now, helping to kind of support our customers who are going through a lot of these digital transformations and Industry 4.0 kind of platform developments. So yeah, very, very happy to be here today. A little bit about the agenda. So I'm going to tackle the first portion of the webinar before handing over to Cara. So we're going to focus on framing quite a lot at the beginning, right? So I always like to focus on the why. So what are the trends that we're seeing? What are the challenges and pain points that a lot of our customers are experiencing when they come to talk to us? And then we will focus on the value proposition of Quix and InfluxDB and how we can address those specific pain points. And then we got we got reference architecture and a couple of customer case studies as well before we jump into the Q&A. So yeah, any questions that you have, please drop them into the Q&A functionality in the Zoom. So let's get started. Focus on the challenges and the trends that we're identifying. So we're seeing, I have done since over the course of the 3 years, kind of increasingly a big shift in the focus towards open and modern technology. So customers kind of beginning to consider these kind of more large scale digital transformations a lot more seriously and undertake them to avoid being left behind, basically. So what you can see on the slide in front of you here is kind of a list of some typical technologies that we would associate to what we call Industry 4.0 use cases. Sorry, there might be a couple of buzzwords here. And then, so those are the technologies. In the center, we would have the Industry 4.0 use cases that those technologies enable. So we consider this to be pretty disruptive tech to the industrial IoT sector. So what we like to say is kind of as the pool of available data kind of grows exponentially, and also the industrial tech and connectivity rapidly evolves, so does the opportunity. And this is the opportunity to uncover value, basically. Digital transformations, the buzzword, is the kind of loose term that we would use to describe this strategic shift in how things are run, enabling your organization to take advantage of the new precious resource, which is data, for a variety of the Industry 4.0 use cases that you can see on the slide here. These digital transformations, we see a big trend towards shifting towards them. And they're pretty vital across the industrial sector to stay competitive and avoid being left behind. But of course, here's one of the challenges with these new use cases enabled by these new technologies comes a new set of roles, skills, challenges, and opportunities. And one of the first blockers we see is this old legacy and rigid technology, often closed and proprietary, and not built to support or facilitate this transition for a number of reasons that we'll get into today. So a lot of these industry leaders and company leaders are looking toward this cutting edge tech to enable and supercharge their use cases and their businesses, use cases or technologies such as AI and ML, cloud computing, edge computing. They want to digitally transform their business to, for example, one of the use cases like improve operational efficiency and reduce costs. We see it as incredibly powerful to your tech stack and maybe even essential that the industrial data platforms of the future support open ecosystems to promote fast pace of innovation and integrations with the best in class tools of the new roles that are looking to take advantage of of these technologies. So just as a really quick example, how do we do that? Or what would be some of the features and capabilities that would be associated to that? So we like to revolve everything around the pain of that particular industry segment. So what we would say here is that to allow enhanced data capture, we would provide a solution that would have very high throughput, cheap storage, or real time and historical query capability, and you could augment that with Quicks to orchestrate your pipeline to help and host deploy models and improve data ingestion and the simplicity there. So what we say is that through having that enhanced data capture and real-time queries, you would have faster time to actionable insights and also a historical analysis capability, which would allow you to, have use cases such as moving from break fix maintenance into preventative and even predictive maintenance to improve that OEE. Just one example there. I will have to apologize to a lot of people on the call to put this in front of you because I appreciate it's probably something that you're all very, very familiar with, but I think it's great just to touch on. So this is the kind of standard network layer cake known as the Purdue model. So what you can see here is the division between the OT, operational technology, and IT realms. So this is a very, very standard model that I'm sure a lot of you are very familiar with. So apologies why I just go back to basics for a few moments. So at level one, as you can see, we've got the time frame of actionable insights is typically, very, very fast, real time, sub-second insights. That's as we go up to level two, you've got the control, that closed loop control plane that they gets a little bit less granular. And as you go up to level three, still in the OT domain, this is your supervisory level. This is your SCADA systems, your HMI, and your historian systems, which interestingly is becoming a little bit of a blended term nowadays. But that's where your kind of insights and actionable insights, historizing tag data typically goes up again, less granularity. Then you hop over the DMZ, that very, very strict network firewall, into the IT domain. And that would be at first at the plant level. That's your manufacturing systems, your supply chain management systems, before you go up to the kind of more global or regional corporate layer. And that would be where your ERPs are. And what I've really tried to just show on this is that the timeframes of the goals and insights required by each of the layers traditionally has gone up as you've kind of moved up that layer cake. And each of these elements, tiers in the layer cake, will have different goals, completely different and unrelated goals and challenges. Now, well, for a while, we've injected very disruptive Industry 4.0 technology, which changes the possibilities, use cases, and goals at each of these levels. So, for example, level three, the supervisory level, IoT enhanced monitoring, anomaly detection, and predictive maintenance use cases can greatly improve effectiveness, reliability, and efficiency. Whereas at level four, you might have more of a quality control and optimized supply chain management kind of use case. The cloud, so this is kind of adjusting data flows and kind of converging the OT IT realms. They're getting a little bit blended. And cloud is often used, you can see at the top of the layer cake there in kind of level five plus. That's described as the sixth or level five beyond level. This is where a lot of those new roles reside that we need to feed to enable your Industry 4.0 use cases. So these are roles such as data scientists, data engineers, business analysts, have a completely separate set of skill sets. But most importantly, they have much higher data requirements and they have an ecosystem of best in class modern and open tools that they want to use to be able to instrument this layer cake and enable your use case basically. So unfortunately, this is where the layer cake kind of breaks down because what you can see is level 5 plus does integrate at various levels. And what I've tried to do, what Kara and I have tried to do, is just kind of instrument each of the levels where we see InfluxDB and Quicks typically being used. So you can see Influx is kind of used level 3 and beyond, whether it's going to be like a traditional like historizing of tag data use case, or whether it's going to be in the IT domain at whatever level. We do it at the edge, regional hubs, global hubs, and this is basically a modern open data storage engine that you can use to facilitate your use case and have that very, very simplified single pane of glass access. And obviously, Quicks is the orchestration solution that you can use to work with InfluxDB and also deploy models to achieve the use cases that you need. Um, so again, really, really simply put, these are just some of the typical goals that we see from customers. Where in the first call, they'll say this use case or this project is to achieve this kind of goal. So ones that come up for us all the time, the kind of trends that we're seeing is if we're focusing on kind of a specific workstation or piece of equipment, it will be around reliability and safety, improving the effectiveness of that overall equipment. Then we go up to kind of the level 4 plant a level use case, which would mostly be around efficiency, downtime, how to implement use cases at that kind of level. So we would call that OOE, equipment operations efficiency, sorry. And then of course, even beyond that, up to kind of the corporate enterprise level, you've got things like waste reduction, supply chain management, looking at optimization when it comes to costs there. And of course, the connection here to InfluxDB and Quicks is time series data. This is the native language of your industrial sensors and equipment, and your assets are shouting at you. Industrial tags, unique signals, collection intervals, events, alarm statuses, telemetry from mobile and stationary assets. Um, your assets have a rich history of a conversation that it's trying to have with you. It's often untapped. And legacy stacks we see as a bit of a bottleneck to tapping into this uncovered resource. They're often, I guess, based on their closed proprietary nature, not capable of listening to this data at the right granularity or serving it to you to enable these particular use cases. So we see collecting and serving this data to be used by this modern ecosystem of tools for any number of those use cases that we saw at the beginning of the presentation, is exactly what InfluxDB and Quick specialize in. So the challenges with managing time series data as applied to Industry 4.0, massive scale. We've mentioned it quite a few times now. So ever increasing data sources and frequencies, your solution needs to support high throughput because you know your data science models are going to want full granularity data over as big a time range as you want. So how can I ingest that information and store it in a cost effective way? Very, very high throughput requirements. Real-time action. So, you're going to want actionable insights to deploy in real time. You're going to want a solution that can operate with streams like Quicks can, and also query in as zero time to be read as possible. So a real focus on real-time action. You don't want a solution that you're going to have to upload data into. It's going to take a day, and then, only in a couple of days you're able to query chunks of data. You want to be able to access it and process it immediately. And cardinality, as the pool of data goes and data sources, the amount of indexes that you're going to have to work across over a vast time range does increase as well. So these are three of the primary challenges we would see. And this is where most legacy solutions, including historians, kind of fall over. So I'll start off with relational data stores, and I would be absolutely wrong if I said that I haven't fallen into this trap if I go back in way back when I was a mechanical engineer developing my first condition monitoring platform. The thing is here, anything works at low scale. It's only when you scale up to anything that resembles a production-esque use case that you will start to see the inefficiencies of not using technologies which is natively developed for it. So, for example, relational data stores are absolutely amazing, amazing pieces of technology. They're a Swiss Army knife that can handle any database workload, but it is really that scale point. I cannot tell you how many customers and prospects I speak to on a weekly basis who all have the same challenges coming from this technology. Typically, they build an MVP or a POC for a small subset of assets, maybe even a small site, which works. And when they scale it up, you will start to notice query response times getting slow, and also the network of materialized views that you need to maintain in order to have a decent query response time to serve your use case becomes unmanageable, the maintenance associated with it, and also the FTEs to maintain it as well. So, that's kind of the thing that InfluxDB and Quix kind of do for breakfast. On the fly aggregates, cost efficient storage, querying by time is what it's natively developed for. And also the lifecycle management of the data, right? Making sure that data retention's built in, that you're not storing any unwanted data for longer than you need to. So yeah, that high scale, minimal time to be read, lightning fast queries, on the fly aggregations, and built in lifecycle management. Similarly, if we just focus on historians, we could spend the whole rest of the webinar digging into this topic. But there's a million reasons why traditional data historians being retrofitted to enable Industry 4.0 use cases are proving to be bottlenecks. And again, I chat to these customers every week. Some of the pain points that our customers come to us with is that these are closed, rigid legacy pieces of technology. So they often represent walled gardens of proprietary tech, which hampers the organization's ability to adapt, innovate, grow, and develop against it. Feed your data scientists in the format that they want to be fed, for example. It's how to integrate with the modern ecosystem because it's closed. That often can be challenging if you're going to have an ecosystem of tools to integrate with. And the fact that it's on-prem often means that sometimes you can have organizational silos, which are kind of dipping into different facilities and things like this. Cost efficiency comes up a lot. There's a lot of reasons why this one is quite a big reason. So, for example, the cost efficiency, but also the cost model is not really suitable for this change in how the industry is changing. So, for example, for traditional historians, you would pay by tag, which means that if you have a high turnover of assets or devices, you're paying for assets that are no longer generating data, and it can massively inflate the size of your renewal if you want to store data indefinitely. And for the modern ecosystem of solutions such as Quix and InfluxDB, we're often a lot more technically scalable and efficient in that domain based on usage or based on compute. We've got a cost model that suits these use cases a lot more, and we focus on that. Vendor lock-in is huge. If these things are proprietary and you're building against them, and they get embedded in your organization, the renewal can be extremely painful and difficult to get out of, and it can be difficult to adapt for new technologies that are coming on the scene as well. And scalability there, a very big reason. So why now? Those are kind of the challenges, a lot of the framing that we would say that a lot of our customers encounter, and why are InfluxDB and Quix the right solution to address these challenges? And I think I don't actually have a slide for this, but I wanted to tackle it on this kind of title slide to say that InfluxDB and Quix represent components in a build solution, right? And that's the beauty of it. You can focus on your use case and you can use the best solutions in the industry to build your tech stack that focuses on your particular use case. We're not a buy option. We're not an off-the-shelf end-to-end solution, which is usually associated with those kind of closed proprietary walled gardens of technology. So have a little think about that. Just the fact that it is a build option and we are components that customers would use to develop their kind of next generation Industry 4.0 platform. So this is really it. I tried to get it all on one slide in a way that wasn't overwhelming. But InfluxDB's unique value proposition is scale. We've mentioned it a few times. We support in version 3 of InfluxDB staggeringly high throughput efficiency and CPU efficiency as well. You can do a lot with a fairly few amount of CPUs. The architecture is distributed, meaning we can fine tune the environment for your workload and apply the CPU exactly where the bottleneck previously would have been in more of the monolithic architecture. So high throughput and unlimited cardinality workloads mean that we can store data, we can ingest data very, very quickly, and also store it indefinitely at low cost. The second reason there, so we've got open standards for seamless interoperability, basically modern and open technology. This three reasons are all very different. Application versatility, we have industry standard and open technology, such as a SQL-based API, such as Parquet files that you can consume, Apache Data Fusion, Apache Arrow, Iceberg. All of these are tools that the industry tools would love to integrate over. So you're kind of future-proofing your tech stack, if that makes sense, and you can continue to apply a lot of different applications as we go on. And had a lot of these projects that have gone through, and they start off just with basic data collection, monitoring, and alerting needs. And then when we check in kind of 6 months' time, they say, we've had 8 new use cases that we've been able to build on top of this platform that we never before thought possible. So I really wanted to drill home that application versatility point. Development agility is similar but different. So this is basically let your developers use the tools that are familiar to them. Client libraries in every major language, a best-in-class REST API. Your developers can move fast. We've kind of reduced building an MVP from months into days. And of course, integrations. Now, any data lake solution that wants to consume Parquet files and work with it, we can integrate with the ecosystem of BI tools that like to query over SQL. We can integrate with. We've really, really doubled down on that open ecosystem point, which again focuses on future proofing, making the platform more versatile, speeding up innovation, and promoting integrations. Real time, we spoke about this again, low latency queries with zero TTBR, focusing on real time analytics, low cost object storage. So, you want to store typically um, full granular information over a vast time range. And I would say this is a really, really important one for industrial IoT customers because usually they have regulatory requirements to store things for 10 years, 15, 20 years. And a lot of previous solutions are just based on SSDs and have fairly basic compression. So now in version 3, we actually see 4 to 6 times better data compression based on Apache Parquet. But obviously now it's an object storage. The unit cost associated to storing that is orders of magnitude cheaper. I think for our managed editions, it's around $50 per terabyte per month. So, basically low cost, infinite cheap storage, which is a really, really key reason to enable these use cases. And deployment flexibility. We're not just in the cloud. We have a multi-tenant solution, a single tenant solution, of fully managed versions, but also we can be deployed on-prem via a software license or a single node solution at the edge on devices. So we have that deployment flexibility. Just to really hit home that open data architecture, this is kind of like a rudimentary data flow diagram, component diagram that you can see. So first thing you'll notice is the logos. We have Apache Parquet, which is the format sat in object storage. And we can also allow you to integrate with the Parquet files directly. So you can basically run non-performance sensitive workloads on the Parquet files directly, usually associated with kind of cold storage tiers and data lake type workloads. So we have a couple of customers who are, using solutions such as Snowflake, Athena, BigQuery, Dremio, Trino to basically set up external tables and query InfluxDB directly. This removes ETL and removes data duplication. It's a really, really nice value proposition for these next gen platforms. Of course, Apache Arrow, that is the natively developed in-memory format of Parquet. A lot of solutions don't have that. So the translation into memory is very, very lightning fast. And it's, a kind of an industry standard solution. Apache Data Fusion, again, an open source project, which is getting a lot of attention at the minute. A lot of the engineers in Influx Data are on the board and promote a lot of the tickets and improvements that go into that project. So you're kind of not just beholden to us for improvements in the query engine. We are now supercharged by this very vibrant open source community. I've had proof of concepts where customers have raised ideas for a new function, a new time series function that they wanted that's very specific to, let's say, energy management or manufacturing. And they've raised it and it's been developed and integrated into Data Fusion by the end of their 2 week POC and they've been able to test it. So that again, that pace of innovation has massively improved. So we're not just based on our proprietary tech where you have to raise a ticket with us anymore. And that's very, very like not to be understated. And then, yeah, that deployment flexibility point again. So you can see a couple of our different offerings we've got here. Serverless, that's the shared infrastructure platform. Very, very low entry point, elastically scalable and usage based, but shared infrastructure. Cloud dedicated is our kind of our flagship product, I guess. That's a single tenant environment. So it has the best performance, maximum stability, and has some additional features like observability, private networking. And that's where you will unlock the unit cost associated with the low cost object storage. And then we have in pink the on-prem equivalent of that. So obviously, sometimes if we're deploying in plant networks, we can't use a cloud version. We have to deploy, either on bare metal servers in an air-gapped environment, or we can deploy on-prem in like a private cloud network for the customer's corporate network. this is one of my favorite slides, but I will say it gets really out of date every time I make it. So what I've tried to do here is make a point. I've tried to make a point about those integrations, and I've tried to categorize them into that tech stack that customers will use to develop these next gen industry 4.0 platforms, whether it's a traditional historian use case, whether it's a SCADA use case, whether it's just an IoT platform use case. And what you can see here is all of these solutions have a built-in native connector for InfluxDB. So we've got the middleware layer. So Telegraph, that's a solution that we've developed that we don't license, that basically is a data collection agent. And you'll notice a lot of different middleware layers there that I'm sure some of you are using, and also Quix. So Quix, this is where Quix will be able to kind of help with the data collection and pipeline orchestration to get data from your industrial data sources and feed it into not just InfluxDB, but any other data source. And I've also dropped Quix in the top right there. So these are all of the platforms that can't really just be categorized into middleware or applications. So Quix obviously has the ability to host models, deploy models, and integrate with different data sources. So it really falls into that kind of platform category. And then at the top as well, we've got different applications that you can use to interrogate the data, which is sat in your InfluxDB. Grafana, super popular, super versatile and flexible. That's what 95% of our customers probably use. Seek is a really, really cool visual application designed for process engineers, charting, trending, identifying anomalies in the profile of a particular asset and looking for that, deploying that and looking for it across all of your different assets. A very, very cool application there. So yeah, just wanted to make a point about all the integrations. So this is really a very rudimentary overview of kind of our recommended architecture, which a lot of customers are going for. So depending what you need, if you have an edge storage requirement or you have a requirement for local storage, InfluxDB has a single node edition that can be deployed at the edge. And then typically we would recommend that you would have a hub. This can either be regional or global. And what this does is give you both a local operational view and a single pane of glass centralized view. And these kind of solve different use cases. The local operational view would typically be your level 3 and level 4 in the Purdue model that we looked at earlier in the presentation. And the hub would be your level 5 or level 5 plus. This would be where you would hang your analytics, the hub, and your reporting off of. It removes data silos, simplifies data access, improves security because you're not going back into the plant network and having to manage that bandwidth relationship. And it allows you to have a local operational view, which is very, very lightweight at the edge. Obviously, Quix is the answer here to how you're going to ship data from the edge into InfluxDB. And a lot of the challenges that a lot of our customers have is over enriching this data with additional context, applying metadata, machine metadata, maybe sending some alerting and doing some stream analytics. And that's really where the value out of Quix comes in as well, in its ability to do that. So this is a really nice reference architecture. I know it's always good to get one of these in. So, exactly, this is showing pretty much the same thing, just zoomed in a little bit. So we got the field controllers in the plant network on the left-hand side, and Quix is being used to basically manage that data pipeline. So it's got a Telegraph, a plugin, so it can be used to scrape data from Telegraph. It can also scrape data directly from your Influx DBs. And now we have some processing in there as well. So we don't just have basic normalization and processing, but we've got some of those advanced use cases associated to Industry 4.0 challenges, predictive maintenance, managing a digital twin, pumping out alerts into wherever you need the work system that you need the alerts to go, and dropping the rest of that data into InfluxDB so it can be consumed by your data scientists, business analysts, data engineers in a manner that's suitable for them, whether it's Grafana or whatever application. So yeah, we've got a couple of customer case studies that we'll be able to find on our websites. And this is one of the nicest ones that we deployed for one of our customers recently, which I think Cara is going to talk about next or soon. So Cara, sorry about that, taking up a lot of time, but yeah, over to you.
Awesome, thank you. No, and yeah, great to already set the scene. I know you've mentioned Quix quite a few times already, but I'll just give a bit more detail. So really, like the core use case for Quix and the Quix telemetry analytics platform is to enable you to centralize all your data into that centralized cloud data store, i.e. InfluxDB, as Ben mentioned. And the first thing here is that we have a lot of out-of-the-box source connectors. So whether that's for edge devices or for popular databases and streaming technologies, so things like whether it's OPC UA or then MQTT, Telegraph, InfluxDB, it's really easy to connect to those sources and get the data in. All of our connectors are open source, so you can also easily fork and customize those if you need to adjust them to your use case. And then if we happen to not have a source or sync connector for the particular technology you're interested in, we have a source and sync API that actually handles a lot of the challenges of connecting two different data destinations together, things like handling back pressure and retries. So that actually building new connectors for new technologies is pretty straightforward as well. And then Quix doesn't just let you build ingestion pipelines. So if we go to the next slide, we'll talk about how we can really easily process data as well. So here, as Ben already mentioned, we don't just mean things like data normalization, downsampling, enriching data from additional metadata in a cache, but we also mean running models, whether it's simple statistical calculations around temperature, pressure, wherever it is you're measuring in your factory or from your devices, but also maybe running more advanced machine learning models in Python or even MATLAB if you are still using that. And really the idea of the kind of low DevOps Quix platform is that it makes it really easy for domain experts to write these models and then effectively one-click deploy them onto live data coming from your factories or test rigs. And at the same time, we've got a lot of functionality in place to actually make your IT teams comfortable to give that power to the domain experts that you have in your business. I think Ben mentioned at the beginning, he used to be a mechanical engineer, and something we see a lot in our customers is that often mechanical engineers understand the physics and the complexity of the machines that they work with really well, but they're not trained software engineers. And so bridging that gap, really giving people the tools to focus on using the data for the modeling or the calculations they want to do, rather than focusing on the plumbing in a way, is what we focus on. And we see this particularly adopted in, for example, R&D teams within industrial companies who want to use Quix to do things like modeling and simulations to really speed up product development, as well as the operational efficiency that Ben already mentioned earlier. Another big part of the Quix value proposition is our templating system. So this is really designed to further decrease time to value and support domain experts with using the data. So we have out-of-the-box templates for common use cases, but customers can also build their own kind of organization internal templates that then their teams can use. And these templates are both at the application level. So whether it's, for example, common ways of doing data transformations, again, things like downsampling, normalization, or common calculations, but it can also be at the project level. So entire pipelines, as some of the examples that you can see on the slide here with the little reference architecture. And all of these are on our website if you want to take a look. I'm aware that the diagrams are a bit small on the slide. But yeah, the point of the templating system is to make it, everything is fully flexible. And this goes back to Ben's point earlier around, this is a build solution. But the idea of Quix and Influx is that you build, but you don't start from scratch. You have these best-in-class tools that really get that step ahead, so that you can get started with custom-built tools, but you can still customize them nicely to your use case and your specific circumstances. And then very similar also to Influx, Quix can be deployed whichever option best fits your business. So we just as Influx does, we offer shared infrastructure to get you started in a very cost-effective way. But then we offer from dedicated node pools to dedicated clusters to then even on-premise deployments for larger and production workloads. So it really depends what your requirements are. We support it all. And then, of course, just as Influx is, we're built on a lot of open technologies, and we have our own open source library for processing the data called QuickStreams. So there really is no vendor lock-in, and you can always kind of lift and shift workloads in and out of Quix as you see fit. Everything is backed by Git, and the whole platform is based on Kafka and Kubernetes. So yeah, very, very much just like Influx do, embrace the open ecosystem and really see the value, especially when you think about Industry 4.0. in really embracing that open ecosystem so that people can integrate with the tools they want to use, because obviously this is changing so quickly and new things are coming up, and we want to enable companies not to get stuck in those old systems and be able to continuously go with the times. But I think that's probably enough about our products and technologies. We do also briefly want to touch on some real world use cases to bring this to life. And so we brought a couple of examples of joint customers and what they do to explain this and give a bit of color. So the first case study we're going to discuss is one in renewable energy storage. So specifically, this is a company that provides energy storage to balance the grid via large battery parks. And so they struggled with their traditional plant monitoring systems as they, as Ben said, provided limited data and specifically limited data granularity, which kind of inhibited having good monitoring and alerting, really understanding if there were issues, where was the issue, how could the issue be solved, when could the issue be solved, etc. And this really, obviously, as the operations grew, this became a really big challenge. And I think especially, I'm no battery expert, but it sounds like the batteries are very temperamental. And so having a really good understanding of how they're performing is crucial. And so that data granularity is really key. And so they built an advanced real-time battery monitoring solution with Quix and Influx DB, measuring things like battery charges, temperatures, etc. And for that purpose, they collect very high frequency sensor data from all the batteries in their battery parks, and then store that at the edge using local Influx V1 deployments. They then use Quix to bring all that data together, normalize it, downsample it, before syncing it to their centralized cloud Influx V3. So exactly that kind of hub and edge model that Ben showed in a previous slide. And they then use Grafana for visualization and alerting. I think the key reason here for going for this combination of Quix and Influx was the ability to effectively handle these very large data volumes of high frequency sensor data coming from the batteries, not just with regards to performance, so actually being able to physically handle that data and bring it together in a timely manner, but also the cost. I think in this scenario, the data volume is just very large, and so it becomes cost prohibitive if the solution is very expensive. Then another example is from one of our customers in machine manufacturing. So again, here they want to measure key metrics like temperature, pressure, motor health, etc., of the machines that they manufacture. And for this purpose, they need to perform a lot of calculations on these metrics as they come in. And obviously performing lots of complex statistical calculations on real-time data in SQL is not ideal. All of the reasons that Ben mentioned earlier in terms of using relational databases, using kind of the traditional BI approach, that's just not made for these kind of data sets. And so here, the key kind of reason for this Quix and Influx stack was actually just being able to write just pure Python, easily writing statistical calculations, building functions, etc., on that streaming data without having to have the expertise of software engineering teams to actually manage the whole thing. And so I think these two examples really highlight some of the challenges that people face that Ben talked throughout this presentation, and really kind of brought to life how they are playing out in industry, and why we think that Influx and Quix together are such a great solution to not just tackle the challenges you have now, but also set you up for the future. Awesome. I think we're now coming towards the end of our presentation. So we should have some time for questions. So I don't know if there's already any questions in the chat, or we'll give people a minute, in the Q&A, if you have any questions on the presentation.
I'll take a look in the Q&A one. There's none there yet. So if anyone has a question that they want to get answered, just drop it in the Q&A tab or the chat, and we'll get to it.
I can see a question, so I will read that out. Maybe Ben, you can take a stab first. So Merlin's asking, what is the path to migrating away from legacy data historians? And can both systems be run alongside one another for a while without any performance hit or network congestion, or is it ideal to read from the legacy data historian initially?
Yeah, great question. And it's a tricky one, right? Especially a lot of these, a lot of our customers try and think about, historians are pretty embedded into these organizations, and it can be quite overwhelming to think about how you can start to move away from it. So I guess typically how we would see is that we would focus on potentially a single facility first. So we would always look to prove it out first for a single facility. Sometimes that's an existing one, or it would be a fresh facility that we would focus on building with the new architecture. But let's just say that, the historian's there to start off with. So typically how a migration looks would be a dual write. So what you would do is we would, however you are writing data into your historian today, we would have a look at middleware options to allow you to basically dual write and replicate that ingestion workload, keeping your historian as it is, serving your production use case, and also populating your Influx DB with fresh data. Quicks can be an option that can help with that as well. So basically, it always starts with a dual write. And then after that will be the question of, do we need a historic data migration or not? And then there comes the activity of a bulk export and a bulk ingest. It obviously depends it just depends on the technology that you have and the data model that you're coming from and going to. But we have a whole ecosystem of configurable tools that can simplify that approach. So don't be too scared by the sound of the word migration. But yeah, typically it starts with a dual write and then a historic data migration, bulk export, bulk import. And we will do a quick sanity check to make sure that all of the data that you expect is there. And it will be a simple A/B deployment switch. So depending on basically updating your query pipelines because the right pipeline is already there. That's how it looks for kind of a full replacement. But as I said, we have a lot of options over, proving it out for a new facility or running a trial first. And what we find is that Influx often starts with one of these new Industry 4.0 use cases. So it will be used as more of kind of an augmentation or a sidecar to start off with. And then over time, bit by bit, we will migrate the historian use cases into InfluxDB and kind of scale down the historian. That seems to be a little bit more of a practical way to do it rather than the kind of do it all in one go. I hope that made sense. I hope that was gave you the answer you needed.
Awesome.
It
Thanks, Ben.
no
Yeah, it
worries.
looks
Looks
like
like we
we've
got
got
another one.
a, yep. Michael's asking, have any customers used Quicks with Synapse? Not to my knowledge is the answer. But that's definitely something we can ask in our community and see if anyone's got experience with that. Be interesting to hear. But yeah, not to my knowledge. But looking at the technology, it looks like it would be a very suitable alternative as well. But yeah. And then I think there's a follow-up question from Merlin. Can Quix Influx ingest data in legacy protocols or structures, or are you always supposed to use new protocols like MQTT as an intermediary? Maybe I can give my answer, Ben can give his. I think probably it always depends what you're trying to do. I think the first part of can they ingest directly? Yes, definitely possible. But depending on what you're trying to do, it might make sense to put it into a streaming technology as an intermediary, for example, as a buffer, if, for example, you also use network connection, etc. So depending on your setup, it might make sense. And we see our customers do both, either directly integrate with SCADA systems or then first put the data from the edge into something like MQTT and then from there read it into Quix and Influx. But Ben, I don't know what you see with your customers.
No, but basically the same answer, but I can give an Influx flavor to it as well. So exactly, we see both. So I'd say sometimes with these kind of small historian extensions or augmentations where a customer might have a very specific use case, they will siphon off the SCADA data or the historian data. So basically you can use pretty much any one of those middleware pieces of technology to integrate with SCADA systems or OPC UA servers. And we've got a variety of I'm sure Quix has a variety of plugins, as does Telegraph, our middleware solution, to integrate with those data sources and write them into InfluxDB as a data sync. But then I would say a lot of our most successful large scale customers would go for more of a future proof approach where they would really focus on the data ingestion portion. So typically by implementing some sort of modern data aggregation point, like using an MQTT buffer or any kind of durable based message queue. Because what that does is not only gives you kind of the throttling and buffering capability, but the other ability to kind of um, focus on stream processing in the future or hang any other additional use cases off of that as well. So we do see both. But yes, both of our technologies have the capability to integrate with most of the major data sources that you would find, such as SCADA systems and historian systems. Yeah, awesome.
I think if we have time for one more question, I have one for you, Ben. I think I'd be really interested to hear from you what you kind of hear the most common pushback when you are, for example, discussing POCs or new projects with customers. What do you think is the biggest reservation in kind of embracing this, what may seem daunting transition towards, if we want to use the buzzword of Industry 4.0?
Yeah, it's I guess a great question. I think, to be honest, it's not usually technical challenges. I think a lot of the challenges that we see are revolving around this kind of vendor lock-in scenario. So it's kind of like, where can we start to prove that we're delivering value for the Industry 4.0 use case that we've selected? Let's say it's um, OEE improvement powered by predictive maintenance and anomaly detection. And basically, what we try and do is make the barrier to entry as seamless and as low as possible, to facilitate that use case and then prove that we can be implemented over more facilities. So it's really that, like, how can they take the first step to getting away from their vendor lock-in situation? Because it can be quite challenging. I would say on top of that, some of the technical challenges that come up are, as Cara and I have said quite a lot, this is a build, not a buy, end-to-end solution. So there are some gaps with just looking at InfluxDB with when you look at specific historian functionality. So, for example, if I chat to prospects that send me historian replacement RFPs, a lot of the time they'll be maintaining the asset hierarchy and asset tag mapping in there is like one of the gaps that we typically have. And one of the reasons the partnership with Quix is so useful and has a great value proposition, because that is probably the major challenge that we get with historian replacements, and it is one of the key things that Quix can actually help to solve. So that was one of the reasons we were so keen to do the joint webinar with those guys, because yeah, it's kind of one of the key things that would customers would look at when they're considering to move to a next gen platform like InfluxDB.
Yep, makes sense, and very much in line with what we see. I think the skills, or like the existing processes and organizations are always a big challenge. I think in cost is another one. I think often data projects cost a lot up front, and then if there's not enough focus on that first incremental business value, I think that can be really challenging. So exactly what you said, picking out a small use case where there's actually tangible business value initially is really crucial in kind of getting started. And then actually, because a lot of these more modern solutions are very extendable and are very open. Typically, once that initial hurdle is overcome, then actually adding the use cases, as you said, is really easy. And so, yeah, that's very aligned with what we see as well. Awesome. There's one more question regarding the build versus buy aspect. In your typical manufacturing company, which role is typically in charge of making all these newer open source modular components talk to another, versus having a monolithic end-to-end historian that the vendor helps you install and run?
Yeah, great question. I don't know, do you want me to jump in first, and then if you have anything to add
Go
to that,
ahead.
Cara, go ahead. Yeah. So you are correct. You know, we're a company that doesn't offer professional services. For example, we offer software, and it can be fully managed that we would run, or if you want it to go on prem, we give you a software license. So typically, we'd be dealing with customers that would deploy and manage this in, they'd have their own IT team that they would use to manage it, or if they're not up for that, we do have a network of professional services partners pretty much across the globe that can be used to do the deployment and maintenance and upkeep of the solution. So you are right. It's a little bit of a difference when you go for that build option. You also get a boatload of professional services that will be looking to run this. With the build option, it's very much the build option with that relationship as well. So I probably see the biggest projects that come through are kind of those top down strategic direction shifts, whereby in the modern age, to be a successful manufacturing company, you also have to be a bit of a successful software company, or to be a successful energy company, you also have to have a pretty nifty software division. So a lot of companies are going through that realization and building up that capability. And we would typically operate through those teams. But as I said, we have a network of really capable partners that can step in to help with that as well. Yeah.
Yeah, I mean, very aligned with what you said. I think we often see that we also provide quite a bit of professional services with our projects just to get people started. And I think that's where actually working with vendors like Influx and Quix, who are really focused on this industry and have a lot of expertise on these specific use case, can also be really help you to guide you and build that data capability internally.
Mhm.
Cool. Well, I think that's all the questions we've had. Thanks everyone for joining. It's been an absolute pleasure, Ben, to have you on board and hear your insights and hear from how you guys work with your customers. And yeah, I think we'll wrap it up there. Thanks everyone for joining and see you soon.
Well, thanks for having me. Looking forward to next time.